All right, let's dive in. Today, we are going to cut through all the noise that surrounds Bitcoin. We're not talking price, we're not talking hype. We are going deep, right into the technology itself, the protocol, which, when you get down to it, is a genuine paradigm shift in how we even think about value. We're going to peel back the layers one by one. So, here's our game plan. We'll kick things off with the simple yet totally radical idea at the heart of Bitcoin. Then, we'll get into its unbreakable ledger and the engine that makes the whole thing run. After that, we'll tackle the whole digital gold debate, the huge challenge of scaling, and finally, where Bitcoin stands today, at a major crossroads. Okay, so to really get this, we have to start with the fundamental problem Bitcoin was trying to solve. You see, our entire modern financial world is built on one thing: trust. We trust banks, we trust governments, we trust somebody in the middle to handle our money. But what if you didn't have to? You know, for years, this was the big puzzle for computer scientists. It's called the double spend problem. In a digital world where you can copy anything with a click, how do you stop me from sending you a digital dollar and then sending that same digital dollar to someone else? Without a central bank watching over everything, it seemed impossible. And then, in 2008, an answer appeared in this white paper: a peer-to-peer electronic cash system. It sounds so straightforward, doesn't it? But this idea was, and still is, profoundly radical. The solution wasn't just a new piece of software. It was a completely new kind of system, a new kind of database, and a new economic model, all rolled into one elegant package. Okay, so how was this radical idea even possible? Well, it all comes down to an invention we now know as the blockchain. And really, at its core, it's a special kind of database, a digital ledger, but one with some really, really unique properties. Let's get into what makes it tick. This whole ledger is built out of what we call blocks. Each block is basically just a container. It's got a timestamp, a bunch of recent transactions packed inside, but the real magic is that third ingredient. Each block has a unique cryptographic fingerprint, a hash of the block that came right before it. That's the chain in blockchain. It's what locks the history in place and makes it incredibly hard to cheat. So how does Bitcoin actually keep track of who owns what? Well, it's pretty different from a bank. A bank gives you an account, right? It's a single balance that goes up and down. Bitcoin uses something called the UTXO model. You can think of it less like a bank account and more like having a pocket full of digital cash, different pieces of unspent value. Your wallet just adds them all up. This is a really key design choice for privacy, since it avoids tying everything you do to one single permanent account. So that's how the value is tracked. But how is the history of that value protected? Well, that cryptographic glue I mentioned, it's an algorithm called SHA-256. And the key thing to understand is this avalanche effect. It means if you tried to go back and change just one tiny detail in an old block, even a single comma, its digital fingerprint would change completely. Boom, that would break the entire chain after it, and the whole network would instantly know something was wrong. So if hashing is what secures the past, the history of the ledger, digital signatures are what secure the present, each individual transaction. When you want to send some Bitcoin, you sign it with your private key. Think of it like a secret password that only you have. This creates a mathematical proof that says, yup, I own these funds and I approve this payment. It proves you're the owner without you ever having to show your password to anyone. Okay, so we've got this super secure, digitally signed, tamper-evident ledger. Fantastic. But who actually runs it? Who gets to add the new blocks of transactions? In a global network with no boss, how on earth does everyone agree on a single version of history? This is where the true genius of the system really shines. The answer is a brilliant and honestly kind of wild idea called proof of work. You can think of it like a massive global competition. These participants, we call miners, use powerful computers to try and solve a really hard puzzle. And here's the crucial part. This isn't just about solving a puzzle for fun. It's an economic security model. By forcing miners to spend real-world resources, electricity, to win the right to add a block, it makes it just way too expensive for an attacker to try and cheat the system. So let's follow the journey of your transaction from the moment you hit send. First, you sign it, and it gets broadcast out to the whole network. It then sits in this kind of digital waiting room called the mempool. Miners then grab your transaction from that pool, bundle it up with a bunch of others into a new block, and start racing to solve that proof of work puzzle. The first one to find the solution gets to add their block to the chain, and bam, your transaction is now confirmed, a permanent part of the global ledger. But what keeps that race fair and predictable? That's the job of something called the difficulty adjustment.
It's like the protocol's internal thermostat or its heartbeat. Every couple of weeks, the network looks at how fast blocks are being found and automatically adjusts how hard the puzzle is. If miners are getting too fast, the puzzle gets harder. If they're slowing down, it gets easier. It's this automatic, self-regulating mechanism that keeps the whole system ticking along at a steady, predictable pace of about 10 minutes per block.
So this incredibly robust, secure, and predictable technical foundation has given birth to a really powerful economic story, a narrative that's driven a huge amount of Bitcoin's adoption and its value. And that's the idea of Bitcoin as digital gold.
And it all starts with this number, 21 million. That's it. There will only ever be 21 million Bitcoin in existence, not one more. This limit is hard-coded right into the protocol, and it can't be changed unless basically everyone on the entire planet agrees to it. This absolute, verifiable scarcity is the bedrock of the digital gold argument. Unlike the money in our bank accounts, which a central bank can decide to print more of anytime they want, Bitcoin's supply is totally fixed. Because of this, a lot of people see it as a powerful hedge against inflation. It's a non-sovereign asset, meaning it exists completely outside the control of any single country or bank.
But, it's not a perfect analogy, and some smart people are waving a big caution flag. A critique from the Wharton School, for example, warns that just calling it digital gold can be dangerously simplistic. They argue that this simple comparison can make people overlook some very unique and complex risks, things related to its digital nature and how it's regulated. It's kind of like how simple financial models before 2008 completely miss the real risks hiding in the system.
And that brings us to what is maybe Bitcoin's biggest challenge, its growing pains. How does a system that was so carefully designed for maximum security and decentralization, how does it handle the traffic when it becomes incredibly popular? This is the scaling problem.
When you're designing a blockchain, you run into this classic engineering trade-off called the scalability trilemma. You have three things you want: decentralization, security, and scalability, which is just a fancy word for speed. The trilemma says you can pick any two, but you can't have all three. And Bitcoin, from day one, made its choice very, very clear. It prioritized decentralization and security above all else. Speed came in a distant third.
And that choice has very real consequences for how fast the network is. The main Bitcoin blockchain can process, at best, maybe 7 transactions per second for the entire world. To put that in perspective, a network like Visa can handle over 24,000 a second. We're not even in the same ballpark. And that low speed is a direct result of the very things, like the 10-minute blocks, that make Bitcoin so secure. So what's the fix? Well, the community's answer is to build on top of Bitcoin. The Lightning Network is what's called a Layer 2 solution. Think of the main blockchain as the secure, slow-moving federal highway system for huge, important shipments. The Lightning Network is like the local city streets, a massive web of payment channels for all the small, everyday transactions that need to be instant and almost free. You do your business on Layer 2 and then settle up on the main chain later. And this brings us right up to today, because after all this development, Bitcoin finds itself at a philosophical crossroads. A really fundamental debate has been brewing about what this amazing technology should actually be used for. What is its true purpose? It's really a battle for Bitcoin's soul. On one side, you have the philosophy of the main Bitcoin core developers. They argue that the base layer is sacred ground, that it should be preserved as pristine money for high-value transactions only. On the other side, you have projects like Bitcoin Knots arguing for the original, permissionless ethos, that the network should be a totally neutral platform processing any transaction that follows the rules, no matter what kind of data is inside it. And so that's the big, unresolved question hanging over Bitcoin today. The choice between these two visions, a carefully curated monetary system on one hand or a neutral open data platform on the other, isn't just a technical disagreement. It's a profound choice about what Bitcoin is and ultimately what it is destined to become.